Up until now, we've worked entirely with ideal op-amps and open loop gains. In this and the following lesson videos, we're going to close the loop and we're going to see what effect feedback has on the application of an op-amp in a circuit. Feedback simply means that a fraction of the output is fed back to the input. Since there are two inputs on an op-amp, there are two types of feedback. Positive feedback is when some of the output is fed back to the non-inverting terminal. This has the effect of increasing the magnitude of the output. Think about that for a moment. If the output was 2 volts, the positive feedback might cause the output to increase to 4 volts. Now the output is 4 volts, so the positive feedback will be bigger and make the output 8 volts. Now the output is 8 volts and so on and so on. Okay, so it's just going to keep getting bigger. In a fraction of a second, the output will be saturated. This is generally not very useful. Well, it is used for guitar feedback, and so some people like it. It's also the same kind of feedback that causes waves to grow big, and the same kind of feedback that can cause stock markets to crash. But we're not going to mention it again, because we're going to focus on negative feedback, as that is a lot more useful and has more applications in everyday electronics. In negative feedback, some of the output is fed back to the inverting terminal, reducing the output. There is one very clear reason why this is good. An ideal op-amp has infinite open loop gain, but by using negative feedback, we can reduce the actual gain to a more useful amount. Maybe we want to multiply the input by 2. Well, now we can. So it's used for performing maths, filtering in circuits for active controllers, and the sorts of things we're going to want to make as electronic engineers. The key thing to take away is that we will use negative feedback in our op-amp circuits to reduce the gain to a useful value. It also has some other benefits though. The stability of the op-amp is increased since it is not working on the edge of its capabilities. There is less distortion of the output. But perhaps most significantly, the bandwidth increases. Hopefully you remember that the bandwidth is the range of frequencies over which the gain is constant. By providing negative feedback and reducing the gain, this range widens, as you can see. So there you have an introduction to feedback. In the following lesson videos, we're going to see it in action as we look at amplifier circuits, and that will give you a better understanding of what's happening.